So correlation, we talked a little bit about yesterday. And let me give you another scatter plot. This one today is going to be kind of rigged so we can use it. The numbers are going to be kind of easy, and we're just going to kind of go through a bit of theory about the scatter plots. Yes, ma'am? Oh, okay. So this scatter plot, could you kind of estimate the correlation, the R that we talked about yesterday? Yeah. Mark, did you know we're doing stats?
Yeah.
Okay. Okay. So, Mark, Hewlett. Shh. Okay. Anybody want to get an estimate on the correlation? It's got to be positive. If you did the linear correlation number, would you give it like a positive 0.99 or a positive 0.5? Maybe 0.7? Okay. So this set of data, we're going to go through and calculate the correlation, and we'll do it by hand, although you'll probably never do it by hand again. I'm reading off the point on the let's see. Where does it say don't show this message again? Okay. I'm reading off from the leftmost point. I see that as 100, 35. What do we want to call it?
35.
All right. And then I see the second one as 200, 50. So you might want to write these down as I call them out. I see the third one as 300, 58. I call the second one 200, 50. The first one 100, 35. The fourth one I see as 400, 61. The fifth one I see as 500, 80. Close enough. 600, 75. And 700, 65. And these are kind of approximates there because I don't think in this little applet I can actually get the point values. All right. So call those out to me.
135, 250.
300, what? 400, 500, 600, and 700, 65, right? Okay. So there's 7 points. Now, if I want to get that correlation number, that number R, one of the ways it's defined is 1 over n minus 1 times the sum of I equals 1 to n, but we don't usually put the endpoints on there, of each x value minus the mean of all the x's divided by the standard deviation of the x's. Whoops, I did that wrong. Standard deviation of the x's times each y value minus the mean of the y's divided by the standard deviation of the y's. Sum those up, multiply those by 1 over n minus 1. That should be our correlation. Okay. Well, yeah, we'll go with the easier way after we do it once by hand, just so you can see where they come from. All right, so, yes, ma'am.
What is the xi?
Xi means each x value. So xi would be x of 1 minus the mean divided by standard deviation.
So just do it for each one of them?
Yeah, there's only 7, so we can do it. It's not going to be too horribly bad here. Okay? So to do this, I'm going to need you to throw the x values into one list in your calculator. We'll go with list 1. The y values into list 2. And I'm going to need a mean and a standard deviation for list 1 and list 2. I happen to already know what n is because I can count. Yeah, really. So I'm going to need some numbers for you here in just a minute. I don't have them in my calculator, so I'm dependent on you. No. I have something else in my calculator that I know I wanted, but now I'm going to clear it out. Hopefully we're getting close. Okay. So there's 7 pairs. So my n is 7. What's the mean of list 1 of the of my explanatory variable? 400. What's its standard deviation? Say it again.
216.
216?
Yeah.
Okay. What's the mean of list 2? And the standard deviation? Oops, S of Y. Standard deviation of list 2, I don't know what I had written there. Nothing yet? 15? Lauren and William. Lauren, cool it. Now you're throwing things. You're acting like a freshman. Yeah, she's throwing things across the room. Okay. Now we'll do our little calculation. You have to take each value, like 100 minus 400 divided by 216 times 35 minus 60 divided by 15. Let's get the first one first. 100 minus the mean of the x's, 400, divided by its standard deviation, 216. And then take, with the 100 was 35. 35 minus that mean, 60, divided by that standard deviation, 15. And see if we can get the right number here. It's not rocket science. Well, I know, it does. See if everybody can come up with the same number. One person's got 2.3. Anybody else got a number yet? Ladies, what did you get for the first number calculation? They got 2.31. So you actually got the same thing? All right, so generally when we get two people getting it, I always turn to this group right here and say, did you get 2.31? Okay. Okay, now you gotta do this for the second point, which is 200, 50. So you got 200 minus 400 divided by 216 times 50 minus 60 divided by 15. So far somebody's gotten 0.617. Anybody else get the number yet?
That looks right.
Put it on there. Right.
No, I got to get verified from somebody else with a calculator.
Do it.
What'd they get?
0.617.
This is cool. How do I get my first list back?
You go to stats, and the bottom button is setup editor. Just click that and click enter, and it'll give you your list back.
0.61.
Okay. Next point is 300, 58.
Wait, zero.
Oh, you can do work with your lists to get this done, right?
Like, you have to plug into L1, L2, and then
No, I just in list 3 I'd put this calculation. Ooh. So if you at the top of list 3, shh. If you at the top of list 3 put parentheses value from list 1, which is second one, minus 400. Oh, I think I'll need another set of parentheses. Close parentheses divided by 216. Close my parentheses again. Times value from list 2 minus 60. Close parentheses divided by 15. Close your parentheses again. I think you'd have the right calculation in here. Let me see if I did that right. List 1 minus 400. What?
Are we looking for what numbers, like after we have all these numbers?
Yeah, then we'll average them all. Times list 2 minus 60. Close it, divided by 15. Oh, yeah. So I get 0.06 for the next one. I get 0 for the one after that. I get 0.617, which you guys were calling 0.61. I don't know about the way you guys round. 0.93, I'm going to round that one up, and 0.46. Okay. That's 7 numbers. You sum those, and then you divide by n minus 1. So you're going to average those, but a kind of funny average. It won't be dividing by, you got 7 numbers, you're only going to divide by 6. So if you got all those numbers, 2.31, 0.61, 0.06, 0, 0.61, 0.93, and 0.46. I'll find my sum here. Plus 3. I get the sum to be 5.
add them up.
Add them up. See what your sum is. You got your sum as 1.96?
I got 4.99.
Okay. So 4.99 or 5.0? And then I do this funny average. And it's 5 divided by n minus 1. There's 7 values, so it's 5 divided by 7 minus 1, which is 5/6, which means my correlation is 0.833. Okay? So a fairly strong linear positive correlation. Okay? How did I get which thing?
5.
5. I added up all those 7 numbers that we calculated. 2.31, 0.61, 0.06.
Oh, okay. Wait, why did you calculate the average?
Why did I calculate the average like that? This is how R is defined. Yeah. And you always subtract 1 when you're dealing with a sample instead of a whole population, and we're dealing kind of with a sample here. Yes, sir.
What's the technical word for what we're doing?
Correlation.
Correlation?
This is correlation.
Thank you.
Okay. So we there? Can I go back to our picture? Come on. There we go. So I have a correlation of 0.83. The other thing that I want to do is make a line of best fit. Okay? So on my picture here, I can make myself a line that I think is a best fitting line. And a line of best fit needs to be the closest to all of the points. So here's one line that may be a line of best fit, but maybe this line's a little better fitting. Maybe this line's a little better. So the line of best fit that we're going to calculate is called the least squares line. And what we do is we take the distance from each one of these points vertically to the line that we think is the best fit line. So let me give you those lines. And then we square the distance from the point to the line. So I can do that visually with a square. We square them so that we won't get 0 when we sum them, because we just want positive numbers. And the least squares regression line has the smallest value when I sum up all of the area of these squares. So if I continue to move my line around, boy, I wonder if I'm doing better or worse to go. Oh, that's obviously worse. That's a lot bigger area.
Right? No, we're not.
Do I need to pull this side a little bit too, maybe? Yeah, right there?
No.
Okay. All right. Right now I have a sum of squares of 415.
Drastically different.
Do you think I could get a little better?
Yeah.
Oh.
No.
I got a 414 over there. Move the other side. 413? Okay. So I can keep dragging this line and dragging this line, but there's also a way of calculating what this line should be. So let the computer do the calculation. Come on. Why is it not doing it? Come on.
I'm perfect.
You really? So because we've got it?
Move it and then try it. Like really out.
No, it's not letting me click that one.
Watch, move it and then click the
Oh, I'm sorry. It went back to the 413. Thank you. We did have the best one. All right. All right. So how do we figure out the equation of that line? Back to the notes. The equation of that perfect line, the one that gave us the smallest area of the squares, it's going to be a line, so it's going to be a y equals mx plus b, but we don't say mx plus b. We'll call it a plus bx. And we won't say y, we say y hat, because that means predicted y.
Y hat?
It's a party hat, yeah. It's a carrot is what it's called. But in stats we call it a y hat. Okay? And if I look at this equation, y hat equals a plus bx, what's a? Is the y-intercept. What's b?
Slope.
Slope. So do I need to put those down? So a is the y-intercept and b is the slope. Okay. So let me go first with the slope calculation. The slope of this line will be the r number we calculated times the standard deviation of that y list divided by the standard deviation of that x list. R was 0.83. Standard deviation of the y list was 15. Standard deviation of the x list was, I'm sorry, how much? 216? So now find the slope for me. This one shouldn't be as hard a calculation, right? So what do you get for your slope? Nice, nice rounding. Thank you for doing proper rounding here. Okay, so there's the slope. Now let me get the y-intercept. The y-intercept is the mean of the y list minus the slope times the mean of the x list. So the mean of the y list was 60, thank you. You said it, didn't you? B is 0.058, and the mean of the x list was 400. So find A for me, my y-intercept. I'm sorry, say it again. 36.8. Okay. So my least squares regression line, we'll abbreviate LSRL, is that y hat, the predicted y value is 36.8 plus 0.058x. Okay, so now I have an equation for that line. Okay, so this line that they put right here, I now know its equation. And I don't know why they don't tell me that. Nope, they don't give me the equation of the line here in this program. Some of the ones that show the least squares do. Okay, so now do you want to keep doing this and doing this way, the long way? Or would you like to know how the calculator does it? Calculator. Okay.
This way.
So whichever way you prefer, I will show you the calculator way. Okay. Button presses. First you push stat.
Did you?
Then you push, you arrow over to calc. And then we want to get a least squares regression line. We use number 8 rather than number 4. So number 8, if you'll arrow down, says linreg a plus bx. That's the one that we want. And then you tell it where your x list and your y list are. So you tell it list 1, comma list 2, and hit enter. And then my calculator from that list gives me that A is 37.4. That's just a difference of rounding that we did. B is 0.058. Oh, we got pretty darn close on that one. And do you see R on your output? Okay. So to set your calculator to get R, you go second, catalog. So that's second 0. And then you go looking for a word called diagnostics on. So arrow down until you get down to the D's, and I think it's diagnostics on. Let's see if I can get down there real quick. Is that the way it's spelled? Taking me a second to get down here because I couldn't get my calculator to go. Diagnostic on. So that's the one that you want to hit enter for.
Did you switch the A to B around?
Hopefully I didn't.
Is it A supposed to be 0.05?
No, we did the A was 36.8. You used number 4 instead of number 8 maybe. It gives you the same numbers, they're just in the other orders. You can use either one, it's fine. Okay, once you turn your diagnostic on, you'll need to do the linear regression command again. And when you do it, it should give you an R. It gives you an R squared and an R. We'll talk about what R squared means. But what does it say R is? 0.8248. Another just difference in rounding, we got 0.83.
Wait, what's second? Second what?
Second, the number 0. That's catalog. And then you can get down to the diagnostic on.
That's it?
So now we have everything that we just calculated. The calculator did it for us. There's other places to find it. But that's one of them. One of the ways of getting it. How do you plug in the A and B? So it just gives you the equation. So now I read the equation off my calculator. Y hat equals 37.4 plus 0.058x with a correlation of 0.82. I look for that in my calculator if I didn't calculate the whole thing by hand. Otherwise, you do the calculation by hand that I showed you. Diagnostic on, all it does is turn on R. It turns on the report of R. That's all its purpose is. Okay? Did you put the X list in list 1 and the Y list in list 2? Did you put the lists in? If you didn't follow through the whole lecture, then you don't have the data in there. But I can show you how to do it different. You can look at the video and follow. All right. I think that's enough for one day.